Hi, now we will discuss the experiment 1, which is the preliminary test and solubility classifications of organic compounds.
Hi, I'm Ma.Alaiza M. Opina.
Hi, I'm Karen M. Estoya.
Hi, now I will discuss to you the theory, principles that can be used in performing experiment 1. The analysis and identifications of unknown organic compounds constitutes a very important aspect of experimental organic chemistry. There is no definite set procedure that can be generally applied to organic qualitative analysis. A major objective of this experiment is separation and identification of unknown organic compounds. So in order to accomplish this goal is to do a preliminary examination of unknown sample that one must not ignore. Among the properties that can be examined in a sample are its physical state, color, odor, and its ignition properties. The physical state of a substance at a room temperature often give clues about the strength of intermolecular forces attractions in the sample. Compounds which exhibit hydrogen bonding, for example, often come in liquid form. However, for those that involve pure van der Waals interactions will come as gaseous form. So the next thing that can be examined that comes to our mind is the number of carbon atoms. Molecules made up of 7 or less carbon atoms are often called as liquids, but molecules that have more atoms are often categorized as solids. Ionic compounds also almost exclusively turn out to be solids under room temperature. Color in an organic compound often indicates extensive conjugation of multiple bonds. The presence of 4 or more conjugated of multiple bonds will usually rise to sharp colors often exhibited by certain groups of compounds such as aldehydes. We cannot with a clear conscience instruct a student to deliberately inhale the odor of an organic compound. Many compounds release fumes that are quite toxic in even in small amounts. So students must therefore be careful in inhaling about the gases released by volatile organic compounds, especially the unknowns. 3 types of information can be obtained from the solubility of an unknown substance. The first piece of information one obtains from the solubility test is the functional group present in the compound. Next is that hydrocarbons cannot dissolve in water, or solubility in water will usually imply the presence of polar functional group. Finally, the number of carbon atoms may also be deduced from its solubility behavior. Acetic acid, which has only 2 carbon atoms, dissolves in water, but benzoic acids, which contain 7 carbon atoms, does not even though, but acetic acid and benzoic acid are carboxylic acid. At the end of the experiment, you will be given an unknown organic compound, which you must classify in terms of its physical state, color, odor, and solubility properties.
So for the first objective of this experiment is to examine various compounds using different preliminary tests.
The second objective is to identify the solubility class of the various organic compounds. The third objective is to examine and identify an unknown compound through preliminary tests and through their solubility classes.
So for the theory, I will now discuss the theory of solubility. There are three factors that can affect the solubility of an organic compound. But first, let us define first what is solubility. It is commonly referred as like dissolves like, which means that polar molecules will generally dissolve in polar solvents, while nonpolar molecules will generally dissolve in nonpolar solvents. So the first factor that affects the solubility is the polarizability of a compound, meaning that organic molecules that are polar are capable of hydrogen bonding and are more soluble in water compared to nonpolar molecules, as shown in the figure in the right corner. Next factor is the number of atoms in a compound. Small molecules are often more soluble than larger molecules, which means that organic molecules that contains more carbon atoms are less soluble. Next is the presence of branching structures. A compound having a branched chain is more soluble compared to a straight chain compounds. So for the acid-base solubility, it also has three factors. First is the structural effect. Most carboxylic acid have dissociation constants in water of 1 times 10 raised to negative 6 or greater, and therefore are readily soluble in 5% hydroxide solutions. Phenols with dissociation constant of 1 times 10 raised to negative 10 are less acidic. Phenols are soluble in strongly basic sodium hydroxide solutions, but insoluble in 5% sodium bicarbonate solutions. So the remaining two principal effects influencing a structural control of acid-base strengths are electronic and steric. So similar electronic influences affect the basicity of amines. So the phenyl rings stabilize the free amines by resonance and also decreases the basicity of nitrogen inductively. So a second phenyl substituent decreases the basicity to such an extent that the amine is no longer measurably basic in water. So last factor is steric effect. Steric strain may either increase or decrease the acidity of carboxylic acid. So in the experiment, there will be 5 solvents that will be used. First is the universal solvent, which is water. Acid and amines generally are more soluble than nonpolar compounds. This is consistent with the fact that the solubility of amines decreases as the basicity decreases. So the amines are highly soluble owing to their tendency to form hydrogen bond with water molecules. Next solvent is hydrochloric acid. Aliphatic amines are readily soluble in 5% hydrochloric acid solutions and are placed in class B if water insoluble. The presence of conjugated aryl groups decreases the basicity of nitrogen atoms. So primary, secondary, and tertiary aliphatic amines form polar ionic salts with hydrochloric acid. Next solvent is sodium hydroxide and sodium bicarbonate solvent. So aldehydes and ketones are sufficiently acidic to react with aqueous alkali to yield ions which serve as reactions intermediate in such reactions as the aldol condensation. Last solvent that will be used in the experiments are sulfuric acid, which compounds such as alkanes, cycloalkanes, and their halogens derivatives are insoluble in sulfuric acid. Simple aromatic hydrocarbons and their halogen derivatives do not undergo sulfonation under these conditions and are insoluble in sulfuric acid.
So for the reagents that were used in this experiment are as follows. Copper nitrate, ethanol, ethanoic acid, diethyl ether, hydrochloric acid, butyl bromide, and butyl bromide. Litmus paper, acetic acid, sucrose, methylamine, benzoic acid, and sodium hydroxide. The next set of reagents are butyl bromide, butyraldehyde, nitrophenol, propanone, sodium bicarbonate, and phenolphthalein.
So for the apparatus that will be used in the experiment are micro test tubes, mortar and pestle, Bunsen burner, hot plate, pipettes, crucible, iron stand, test tube rock, clay triangle, and iron ring.
One of the objectives of this experiment is to examine various compounds using different preliminary tests. So for these tests, compounds that were needed are copper nitrate, acetic acid, and an unknown. For the procedure in this test, you need to observe the following properties for the compound. The physical state, in which you need to note whether the compound is solid or liquid. Second is the color. Third is the odor, in which you need to examine the odor of the unknown compound. And fourth is the ignition test. This ignition test is a test for the presence of any metals in a compound. So for the procedure of this ignition test, the first procedure is you need to place a small amount, approximately 0.10 grams if solid and 0.50 ml if liquid of a substance in a porcelain crucible. The second procedure is you're going to hit it by increasing the flame slowly until the ignition is complete, then cover the crucible. While doing the second procedure, you're going to observe the following: the flammability and nature of the flame. If the compound is solid, note whether it melts and note the manner by which it melts. And the odor of the vapor or gases evolves, if any, and the residue left after the ignition, if any. And if a residue is left, add a drop of the distilled water and test the solution with litmus paper. Add a drop of 15% of hydrochloric acid and note if the gas evolved. And lastly, you need to perform a flame test on the solution produced using nichrome wire in order to determine the metal present.
So for the next procedure is the solubility classification test. There will be 5 solvents that will be used, such as the water, ether, 5% hydrochloric acid, 5% sodium hydroxide, 5% sodium bicarbonate, and cold sulfuric acid. And there will be 10 test compounds that will be used as listed in the table. So for the first procedure, you must place 1 ml of each solvent into the micro test tubes. It is then followed by using a dropper, add a drop of test compound in each test tubes. So the test compounds will be also tested in litmus paper and in a phenolphthalein. Careful not to add too much solute or too much solvent because it may mislead you in identifying the solubility. It is therefore important you determine the extent of solubility of the compound under test. If your solid unknown is in the form of large crystal, it is advisable that you pound it using mortar and pestle. So it is advisable to follow scheme 1.1 for identifying the solubility of your test compound. It is also noted that sulfuric acid is used as one of the test solvent and a color change rather than a solution is usually observed. If this happens, consider it as a positive test. After performing the experiment, you must record your observations in the data sheet.
So for this schematic diagram, as you can see in the PowerPoint, this can be used as a guide for the solubility testing. Using this whole diagram, you can identify the solubility class of several organic compounds after testing the solubility properties. And the meaning of each solubility class, as you can see in the diagram, is summarized at the table that follows.
So for the solubility class table is shown in the presentation. You will determine the solubility of organic compounds based on the table shown in the presentation. So each functional group has a set of particular chemical properties that needed to be identified. Some of these properties can be demonstrated by observing solubility behavior, while others can be in chemical reactions that are accompanied by color changes, precipitation formation, or other visible effects. So according to the presence of their functional group, organic compounds can be classified in different families and class, as shown in the table. So class A are for salts of organic acids, amine hydrochlorides, amino acids, and so on. And class SN is for alcohols, aldehydes, ketones, amide, and esters. For class SA for carboxylic acid, class SB is for the aliphatic and aromatic amines. Class B is for aliphatic amines. Class A is for strong organic acids. Class A2 is for weak organic acids. Class N is for alcohols, aldehydes, ketones, esters, and lastly, class X is for saturated hydrocarbons.
So for the conclusion, performing the tests on known samples served as a baseline for the known samples.
So for the last two conclusions, the identities of the test samples were compared to its expected result and matched, making this test fairly accurate based on the given general data. Therefore, being able to classify the functional groups present are greatly beneficial in identifying the unknowns.